This lesson is about scaling. Fundamentally, there are two ways to do the scaling of a polygon. You can change the size of the rendered drawing, or you can change the position of the points being drawn. At first, it may sound like the results would be the same, but there is a definite difference. This is an example of scaling a drawing. This is a drawing of the polygon without scaling. And this draws a scaled-up version of the polygon. This scale method call increases the size of everything drawn by a factor of 3 in the x direction and 3 in the y direction. It looks like this. In this example, not only is the figure drawn 3 times as large as the original, but the lines are also made 3 times thicker. That's because of the way the affine transform works. It works pixel by pixel while the figure is being drawn. That is, when something is increased in size by scaling, the entire image is increased, causing each single pixel of the original figure to cover more real estate, so the lines get thicker. If you want to scale a figure without thickening the lines, you can use a transform to scale the points before the figure is drawn. Now these two new arrays, x2 and y2, are used to contain a scaled version of the figure. Notice this is done in the constructor. Here is an affine transform that's being set to scale up the size by a factor of 3 in both directions. Here, inside the loop, each of the pair of x and y points is stored in the PT array. The reason for doing this way is to put the point into a form that the affine transform object can understand. Now this method call right here will transform the points by applying the scaling factor to them. Then the transformed points are converted to integers and stored in the new array holding the new figure. These statements apply a translation to move the center of the figure out into the window and then draw the figure from the previously transformed points. Now this is what it looks like. This figure shows the scaling to be the same size as the previous one, but with this one, only the points were moved. The lines were drawn in the same thickness for both figures. Now, here is an example that demonstrates scaling up, scaling down, and rotation. Now this program presents some values used for scaling the figure, and it draws several copies of the figure in a loop. For this, the first drawing, the figure uses the value of scale up for scaling the figure in both the x and y directions. The scale up value is set to 1 initially, and that's the way it is the first time through the loop, so no actual scaling is done. It also uses the variable named angle for rotation, which is initialized to 0, so the first time through the loop there is no rotation. Now this figure is drawn in much the same way, except 100 is added to the y offset, so the figure is further down in the window, and the value of scale down is used for scaling instead of scale up in the x-y directions. Here at the bottom of the loop, the values are adjusted. The x offset is moved to the right by 30 pixels. The scale up and scale down values are changed, so the next time through the loop, both figures will be a different size. The angle is increased, so the next figures will be drawn rotated slightly more to the right than the ones before it. It looks like this.